Good morning to all of you. Today's topic is solution of algebraic and transcendental equations. As per your syllabus, we will be covering two topics here, the bisection method and the Newton-Raphson method. Just a second. Okay, so as per your syllabus, we will be covering two methods, the bisection method and the Newton-Raphson method. We will be solving algebraic and transcendental equations. Just a second. The notes will be given to you. Okay, so you can check here that we will be solving equations of this type. Fx is equals to 0. Your equations will be of the form fx equals to 0. And you have an example of algebraic equation 5x7 3x square plus 7x plus 7 equals to 0, so on. So these are your algebraic equations where you have the coefficients and the variables given, and these are your transcendental equations where you have ex, log x and cos x involved. So these are the examples of transcendental equations: e to the power x, 3 log e base x to the power x, cos x equals to 0. Okay, so I just opened this PDF just now to show you some of the algebraic and transcendental equations. Okay, so next we move on to bisection method. Later on you can read through all this. I am not going into details of all this. This is your reading material just now. Okay, so we are solving equations of the form fx equals to 0, and we will be involving both algebraic equations and transcendental equations. Okay, so as far bisection method is involved, we will be just doing this much, that the bisection method is an iterative method. You can read the reading material later on. This is what is to be written just now, that bisection method is an iterative method. So you will be having iteration 1, 2, 3, 4 and so on. It is an iterative method to be remembered, and we will be defining the function fx continuous. The function fx should be continuous in the interval ab, should be continuous in the interval ab. There should be an interval ab where the function is to be continuous in the interval ab, and fa into fb should be less than 0. fa into fb should be less than 0. So these are the two criteria which are required. Okay. So my first criteria is that given there will be a function fx equals to 0, whose roots you are finding or solving the equation. So this function has to be continuous. Check on the spelling. I wrote it wrong actually. Okay, so you have to insert a u here. Okay, so the function has to be continuous in the interval ab. and you should get FA into FB less than 0. Okay, that means one of them has to be positive, the other has to be negative. Then only the product is negative. Okay, both cannot be positive or both cannot be negative. So FA into FB is less than 0 means that one of them is positive and one of them is negative. Then there exists at least one root, then there exists at least one root, then there exists at least one root between AB. So this is the theory which we will be using just now for finding the root of the equation fx equals to 0. You can read all this later on. I'm not going into all these details. So only this is to be remembered just now, that bisection is an iterative method. You are finding the root of the equation fx equals to 0. Fx has to be continuous in AB and FA into FB should be 0. That means if I multiply FA, FB, it should be negative. Then there exists at least one root. Then there exists at least one root. Then there exists at least one root between AB. Okay. So this is what we will be using and this is what we will be doing. Okay, so let us move on to an example now. So suppose you have to solve the equation. So you have to solve the equation x cube minus 9x plus 1 equals to 0. You have to solve this equation for the root lying between 2 and 3. So it is given that the root lies between 2 and 3. For the root lying between 2 and 3. Correct to 3 significant figures. Correct to 3 significant figures. Okay, so this is your question. You have to solve the equation x cube minus 9x plus 1 equals to 0 for the root lying between 2 and 3, correct to 3 significant figures. So here it is mentioned that the root is lying between 2 and 3. There may be instances where it will be not mentioned. You have to find the root lies between which two numbers by trial and error. Okay. So just now we will be solving questions where it will be given that the root lies between which two intervals. So you don't have to go through that process. Okay. Okay. So is there any question till here? I hope I am audible to you and you can see the whiteboard, whatever we are writing and doing. Just any one of you please respond. Okay, fine. So we continue therefore. Srijita has confirmed me. Okay, so we are solving x cube minus 9x plus 1 0 for the root between 2 and 3. So my first step will be the root lies between 2 and 3. So find f2 and f3. I have to confirm that the root lies between 2 and 3 before I proceed. So in this case, fx is equals to x cube minus 9x plus 1. This is my fx, x cube minus 9x plus 1. So can you tell me the value of f2 and f3? So what will be the value of f2 and f3? Fx is x cube minus 9x plus 1. So please solve for f2 and f3. Orko check f2 is not 0 Yes, Azuzur got that right. Yes, Ria and Aditi also correctly answered. Yes, Srijita also correct. Orko corrected. How much is F2? Yes, right, -9. So we get F2 as -9. Actually, the value is not important here. It is negative that is more important. But yes, I need the value. Otherwise, how will I say? And F3 is 1, which is positive. So it is confirmed that F2, F3 is negative. One has to be positive, one has to be negative. Okay. Then the product is negative. So what we are doing now here, the root is between 2 and 3. This is the interval. The root is between 2 and 3. This is the interval. So at 2 it is negative and at 3 it is positive. When I say at 2 it is negative, I mean the function is negative. So I'm just not using the word function. Okay. So at the given, between the given interval 2 and 3, at 2 the function is negative and at 3 the function is positive. Okay. Hence, I get that the root lies between 2 and 3. So this is my first step. So before going to the computational table, we are just showing you with this diagram that how the bisection method goes about. Okay. So one has to be positive, one has to be negative. I mean the function. Okay. Therefore, the root lies between 2 and 3. Anyone has any question till here? Have you got it? You keep the graphical representation, it will help, and then I will go to the computational table also after this. So the root which you will be finding will have a value which is more than 2 and less than 2, less than 3. That means 2 point something will be your final answer. Okay. Since the root lies between 2 and 3, it means that your answer is something more than 2 and something less than 2. I'm sure you got that. Anyone has any question till here? Just check on if you are understanding what we are doing. Okay, very good. So you got till here, no problem till here. Anyone has any question, anything to ask till here? Okay, so now what we do, we found out that F2 is negative and F3 is positive. Here we have told you that bisection for bisection method, which is an iterative method, Fx has to be continuous. This is one criteria, and Fa into Fb should be less than 0. This is the second criteria. Then there exists at least one root between A and B. So if I want that the root should lie between A and B, I should get Fa into Fb equals to 0. Shubhashachi, can you see that? Have you got it? So this is what we are doing here. Okay. So we have said that F2 into F3 is negative. One is positive, one is negative. Therefore, F2, F3 negative. So we have confirmed from the question just now that the root lies between 2 and 3. This is what we have done at the beginning. We are just confirming what is given in the question, that the root lies between 2 and 3. Okay. Now we find the middle point of 2 and 3. This is our next work. So what is the middle point of 2 and 3? I'm sure all of you can get it. That is 2.5. Okay. So the middle point of 2 and 3 is 2.5. Next, my work is to find F 2.5. So this middle point I will find, and then I will compute how much is F of that. So again, the value is not important. If 2.5 is positive or negative, that is important. So please tell me how much is F 2.5? Okay, very good. Srijita has computed F2.5. Anyone else? You know fx is x cube minus 9x plus 1. You just have to compute F2.5. Yes, Shobhashachi has also done. Yes, Azizur has also got the answer, right? So, yes, Suresh has also done. So, what we get from all of you that F2.5 is negative. So, the value is minus, yes, Sweta and Pratusha also got it. Minus, yes, Orko, minus 5.875, right? So, the important part is that F2.5 is negative. Okay. So, now we say that the root lies between 2.5 and 3. Here is the root. Okay. So we began that the root lies between 2 and 3. Now we say that the root lies between 2.5 and 3. Now we take the midpoint next of 2.5 and 3. So what is the midpoint of 2.5 and 3? So what will be the midpoint of 2.5 and 3? Yes, right, 2.75. 2.75, check. So next compute f of 2.75. Next compute f of 2.75. I mean it is positive or negative. That is what is important here. We just want to know if that is positive or negative. Function is x cube minus 9x plus 1. Yes, correct, Pratusha. Just let me check on the rest of you. Ria, check your calculations. Yes, Srijita also got it. Okay, so we get negative. Therefore, so F 2.75, yes, correct, Azizu, is negative. So now we say that the root lies between 2.75 and 3. And we find out the middle point of 2.75 and 3. So what is the middle point of 2.75 and 3? So what will be the middle point of 2.75 and 3? Yes, 2.88, correct. And we move on, okay? So this is your bisection method. This is what we will be doing. This is the iteration, okay? So this is what we are doing again and again. We are finding the midpoint and we are computing. This is the iteration we are doing again and again, okay? Now I move on to the iterative table. Anyone has any question till here? So the root was between 2 and 3. So till this iteration, I got the root to be 2.88. This is my root. These midpoints are the roots only. Okay. So you can see the root was between 2 and 3. So till here, I got the root to be 2.88. But I have to proceed more till I get the required accuracy. That I will tell you from the table where to stop. Okay. But this is what we will be doing again and again. And these midpoints which we are finding, these are the roots only. This is not your final answer. I will tell you what is the stopping criteria, but again and again, this is what we will be doing. Okay, so I ask you again, is there anyone with any question till here? This is the concept. No, not that until it comes positive. No, Sweta. When two consecutive steps will give me the same answer, there we stop. Okay. Positive is definitely because the root is between 2 and 3. Understand the question. It's saying the root lies between 2 and 3. So your final answer is something which is more than 2 and less than 3. So there is no problem in getting something which is positive. Okay. We have to get the same answer in 2 consecutive steps. Okay, Sweta, there we stop. But I will show you that in the table we do now. Yes, this is for your understanding. Okay. So you will not do like this in in your exam or when you solve. This is only for your self-understanding that we did it in like this. Okay. So now I tell you actually how you will proceed. So let us open a new fresh whiteboard. Okay. And let us start it once more. That part, what I showed you, it was for your understanding. So you start the solution like this, that fx is equals to x is cube minus 9x plus 1. This is given in the question only. X is cube minus 9x plus 1. In some cases, it will be not given. The root lies between which two numbers? We will do those type of questions later. There you have to find out by trial. You have to put different values and check. Okay. So now it is given. So comfortably, I will just confirm that if F2 and F3 are giving the product as negative, FA, FB should be less than 0. So F2 is minus 9 and F1, sorry, not F1, F3. F2 is minus 9 and F3 is 1. So I got here FA, FB to be negative. So I just verified and kept it. Okay, that F2 into F3 is negative. And I say, okay, fine. The root lies between 2 and 3. Okay. After this is the solution actually which we are doing. After this, we form the computational table. Okay. So my computational table will have first column, the number of iterations n. The next column will be an. Then the next column will be bn. Then the next column will be xn plus 1, which is an plus bn by 2. And my final column will be f of xn plus 1. Okay. So these are my columns and I will proceed. So my first column will be n, the number of iterations. Then I have an, then I have bn, then I have xn plus 1, the midpoints. And these are the roots. This column will give you the roots. Okay. 2 consecutive steps, I should get the same value. There I stop. And as per the question, don't forget the question, correct to 3 significant figures. Okay. So keep 4-5 places after decimals. Then only you will get correct to 3 significant figures. Keep little more. If I am talking about 3 significant figures, better to keep 3 and 4 decimal places for 3 significant figures. Okay. Anyone, any question till here? Anyone wants to ask anything till here? Okay, because please understand and do it. Take your time. If you do one question very well with your understanding, rest of them will be similar. This is the good thing about your numerical methods. You just need to understand it once. Then only the equation changes and your calculations in the calculator changes, which is much simpler, much easier. So understanding the question is very, very important. Okay. Don't compromise on it because I'm stopping and asking you also in between. Okay. Okay.
Ma'am,
Yes.
and why have you stopped at 2.88?
No, we will continue. It was just I was just showing you how to do it. This is not the final step. Again, you have to proceed. You have to stop only when 2 consecutive steps gives you the same answer. Okay. So I haven't stopped here. Actually, this was a graphical representation only for your self understanding. This is how you will do the question in the paper or in the exam. I mean, with this table, you will not do it the way we did there. So this is why I stopped there. That was only to show you what is actually happening. Okay. So this is the real method. This is, you have to do it in this table form, not in that form, which we were writing and doing. Okay. But we will do the same thing only. The representation is different. Here also we will find the midpoint. Here also we will find the function. Okay. But you have to do it in this tabular form. Have you got that, Sweta? Here we were not doing in tabular form. So I stopped. You will not do like this drawing pictures. Maths cannot be done like this. No, this is only for your understanding that I showed like this. By drawing, this is actually by drawing pictures. You have to do in that table, not like this.
Okay,
Have you
ma'am.
got it, Sweta?
Yes, ma'am.
Okay, so this was just an demo I was showing that this is how you have to proceed. But actually, will not do like this in the copy. In the copy, this is how you start. You will write fx, you will find FAFB, you will show that FAFB is less than 0, and this is the table which you will form and you will proceed. Okay, so the root lies between 2 and 3. That means this is 2 and this is 3. A is 2 and B is 3. That's very obvious. If the root lies between 2 and 3, your A is 2 and B is 3. So F2 is negative. So we designate this column as negative. Since F2 is negative, we designate this column as negative. And since F3 is positive, we designate this column as positive. This is my next work. Okay. So the AN column is negative and the BN column is positive. I hope you understand why. Because my F2 was negative and my F3 was positive. Now the starting initial iteration. So AN is 2, BN is 3. The midpoint is 2.5. Okay. So AN is 2, BN is 3. The midpoint is 2.5. And if I compute f of 2.5, I get a negative answer. Minus 5.8. That's all of you had computed, if you remember, just few minutes back. Okay. So this is the, again, the value is not important. The function is positive or negative. That is important, as I had mentioned you. Okay. So f of 2.5 is negative. So I have put negative sign in the last column. Okay. Now, if the function is negative at 2.5, so this new value 2.5 goes to the negative column. Okay. So I will be having 2.5, the new xn plus 1 actually here in the negative column, and the positive column will remain same. This is my next iteration. So now the root lies between 2.5 and 3. But how to put it? That's the shortcut. Okay. Here we were doing, you can check here. When we were doing here, we said that the root lies between 2.5 and 3. We were putting like this, negative, positive. But when I do in a table, this is the shortcut we will be using. Later on, you can compare both the methods, table and graph. Let's not now look at both the things. Let us look only at the table now. So if I get a negative here, the xn plus 1, this 2.5 goes to the negative column. Okay. And the positive column remains same. Okay. What is the midpoint of 2.5 and 3? 2.75. And I again got the function negative here. So 2.75 will go now to the again negative column. So next iteration, here I have 2.75 and here I have 3. The positive column remains same. Okay. What is the midpoint of this? The midpoint of this is 2.88. And again, I had computed that this is negative. 2.88 was negative, the function. So in the next iteration, 2.88 goes to the negative column and the positive column remains same. Okay, so just check on if you have understood till here. And if there is any question, please let me know. Have you got till the third iteration what we have done? You people have been solving till here also. Okay? Okay, fine. Shirish, can you tell me what will be the next xn plus 1? What will be the next xn plus 1? Right, 2.94. That's the midpoint of this. Right. And what about the function? Is it positive or negative? I mean, how much is f 2.94? Yes, so again we have negative, okay? Minus 0.05. So in the fourth iteration, your 2.94 goes to the negative column and the positive column remains same. Okay, what's the next xn plus 1? What's the next xn plus 1? Yes, 2.97, right. And what about the function? Is it positive or is it negative? Yes, positive, correct. So we got after all these steps a positive value here. So can you tell me now in the fifth iteration, what will be the value of an and bn? So what will be the value of an and bn? Okay, since the function is positive, so the new xn plus 1 will go to the positive value, go to the positive column. Okay, so in this case 2.94 remains same, no change for that, and here I get 2.97. Right, whoever answered right answered correctly. Okay, so in this case, since the function is positive, so my new xn plus 1 goes to the positive column. So 2.94 remains same in the negative column and the new 2.97 goes to the positive column. Okay, and the middle point is next 2.955, right? And here I will have again positive value. So in the sixth iteration, the negative value remains the same and the new positive value goes to the positive column, that is 2.955. The middle point is again 2.9475. And we have computed positive here. Then we have the seventh iteration. Okay, since it is positive, the negative column is same. Okay, so no change here, 2.94. And we have in this case 2.9475, the new value. And the midpoint is in this case 2.9438. And we get a positive here. So we check that we already got 2.94 in two consecutive steps. So we are almost at the end. 3 significant figures was required. Okay. So I got 2.94 in two consecutive steps correct to 3 significant figures. Okay. but I will be not checking only xn plus 1. I have to check an and bn column also. So this is why one more step we will go about with the last step, the 8th step. So in the 8th step, this is positive, means 2.94 remains same. The negative column is same. And in the positive column, we have the new value 2.9438. And the midpoint will be 2.9419. Okay, so now I can see that in N column, same value, in Bn column, also same value, and in Xn plus 1 column, also same value. So all the 3 columns in 2 consecutive steps should have the same value. Now I stop. Okay, and my answer is 2.94. My final answer is 2.94, and that I obtain from the xn plus 1 column. Okay, and we stop here. 3 significant figures they had asked you. So 2.94 is 3 significant figures. So my final answer is x is equals to 2.94. That's the root. X is equals to 2.94. Okay. So I am stopping whenever 2 consecutive steps is giving me same value for an, bn and xn plus 1. That's my stopping criteria. Okay, so this question is done here in the PPT. You can check it. So in the 8th step, n, bn, xn plus 1 are equal up to 3 significant figures. So the root is 2.94. Okay, so I give you a few seconds. This is printed better, not handwritten. So you can, what it is same what we have just done. So please go through this and tell me if there is anything which you have not understood. I will take your attendance in the meantime. Any questions? You can unmute and you can ask me. Anything you have not understood?
Ma'am, I was asking that if in between any of this value, suppose we get in the any of the step we get fxn plus 1 equals to 0. Now at that time, what will be the x value? The midpoint, the xn plus 1, that will be the x value.
I'm just coming to you. Just a second.
Okay. Ma'am.
Okay. Suppose you get the function to be 0 at a particular point. What does that signify? It is the root of the equation. You don't have to do anything further. Your function is fx equals to 0. Okay? If at any certain particular point you get 0, that means that is the root itself. You don't have to do anything further. Does that satisfy your query? That's logical, no? The function is fx0. So if at certain point you get 0, that means that is the root of that equation.
Yes, ma'am. Now
Yes or
suppose,
no?
yes, ma'am. Suppose we get at a certain value of a and b. Suppose we get xn plus 1 if we put that xn plus 1 in the function, we get 0. So our x is going to be that
Yes,
fxn plus.
then yes, it's over. Nothing more to do. That's the root
Okay.
of that equation. That means that value satisfies the equation, isn't it? So then there is no further steps required. That itself becomes the root of the equation and the work is over. Have you got it?
Yes,
Xn
ma'am.
plus 1 are the roots only. We are going towards approximations, okay? And in case we get the function as 0 at any point, that means it's very good. It's done. That's the exact root actually. These are the approximate roots. This xn plus 1's root is this column only. This is the root column. Okay, this is the answer column. So when I am getting for xn plus 1 positive and negative, you can see I am very close to the root because numerical methods are approximate methods. Now particularly if xn plus 1 is 0, that's the exact root you got therefore. Think you can have any equation, okay? Some value of x totally satisfies the equation. That means the function is 0. That means it is the exact solution actually, isn't it? Anyone else wants to comment on this? Am I saying something different? Is it making sense? Have you got that? When
Yes,
the
ma'am.
function is 0, it is the exact root therefore, isn't it?
Yes, ma'am. And now one more thing here. The table that we have done, we have gone through 8 steps, means total 9 steps. But here I can see that in the answer in get is giving the PDF, they are going for one more step. What is the
Yes.
reason for?
It's a check only. They are confirming that accuracy. See, numerical methods means the more accurate you can give. Okay, these are approximate methods again. You are finding the root of the equation. Okay, so the roots are approximate values. So here it is up to 3 significant figures. It can be up to 4 significant figures. It can be up to 2 decimal places. Either they will ask you the solution for certain significant figures or they will ask you for certain decimal places. This is how it goes about with. I think the class will end. Okay, we continue in the next class
Okay, ma'am.
because it's 10:50. It will just finish. Most of you have joined. So we were at this question. So I was trying to tell you that these are all approximate methods, numerical methods. Okay. So you are finding actually the approximate root. So when you are finding the approximate root of a certain equation, it will be mentioned in the question that how many significant figures or how many decimal places are required. So generally 3 to 4 significant figures and 3 to 4 decimal places. You don't have something which contains lot of decimal places and significant figures, okay? And you should keep little more because it will be rounding off at the end. So if it is 2 decimal places, keep till 4. So here it was 3 significant figures, so they have kept till 4 decimal places so that you can round off at the end. Otherwise, the accuracy problem is there, okay? So this is why they have gone for one extra step, that is the 9th step, just to check on that you are getting the same values. Okay, so your stopping criteria is when you get same values for all the 3 columns. Okay, so you can see 2.94 for an, but the value of an is not the root. Okay, the value is here, xn plus 1 is the root. Keep that in mind. You may, by chance you got all same here, you may not get also always. Okay, but yes, the root is lying between these 2 numbers, so it will be close enough. So 2.94, 2.94, and here also 2.94, 2.94. So all 2.94 I got and I stop. Okay, so I hope that's clear. Bisection method. All of you have got that. And since you have got that, I move on to one more question for bisection method for you, which you can solve and you can tell me.
Ma'am, if FA
Yes.
and FP is 0, then No, it's greater than 0. Then
the root doesn't lie between those two numbers. You must get one positive, one negative. It will be always like that because you have started like this. You have started with the column which is negative and it is positive. You have already started like this, okay? So always you will get one negative and one positive because the root lies between 2 and 3. That's where you started. So it won't be that both are positive. You will not get. Computationally, it will not happen. Okay, so please try one more question on your own. That will help you actually to understand it better. We will solve it together actually. Okay, so compute the root of log x equals to cos x. So this is the equation. Log x is equals to cos x. Correct to two decimal places. Correct to two decimal places. The root lies between 1 and 2. So that's the transcendental equation. It's good. You will have a practice. Okay, so let's proceed without wasting time. You have to compute the root of log x equals to cos x. Correct to two decimal places and the root lies between 1 and 2. That's your question. So we begin with the function fx, which is log, nothing is mentioned means e base, okay? Log e base x minus cos x. It should have been mentioned. Anyway, it's log e base x. So the function is log e base x cos x. The root lies between 1 and 2. You are lucky, it is mentioned. So you don't have to find actually by trial method. So just you have to confirm that f1 into f2 is negative. So find the value of f1 and find the value of f2 and tell me how much you are getting. How much is f1 and how much is f2? Yes, right. Minus 0.54. Srijita, check. Don't forget radian mode. Cos, not degree mode. So F1 is minus 0.54. So that's negative. Srijita, check your answers. I think you are not using the radian mode. Yes, F2 is positive 1.1093. Okay. So now you form the table and proceed in solving. An, Bn, xn plus 1 and the function. 4 columns are required. So my first column is An, second column is Bn, then I have xn plus 1, which is An plus Bn by 2, and f of xn plus 1.
Ma'am, my F2 is 0.717.
You are using degree mode and not radian mode. You have to change your calculator to radian mode for calculation of cos x.
Ma'am, in radian mode, the value of cos 2 is minus 0.4161.
Check log ebex minus cos x. Just do it. Some addition, subtraction, something you are going wrong. You have to find log e base 2 also. You should get it. So many of them got it. Srijita, have you got my 1.1093? So Sweta, you should also get, because so many of them got it. Just check it, Sweta. There is no reason why you will not get it. Log e base 2 minus cos 2. Okay, so 1 and 2. An is negative. So this is my negative column. Bn is positive. This is my positive column. Okay, so what is the value of xn plus 1? 1.5, very obvious. At 1.5, what is the value of the function? Yes, 0.33. Right, Srijita and Azizur, correct. So here it is positive. So now because it is positive, so in the next iteration, 1.5 will go to the positive column. Okay, so here I put 1.5 and the negative column remains the same. So now the root lies between 1 and 1.5. Okay, what's the middle point? 1.25. So please calculate f of 1.25. That means you got something negative. Azizur and Srijita both got the same answer. Very good. I don't have the solution to this actually, the first part. So I'm just going by what you are doing. So negative means xn plus 1 will go to the negative column. So xn plus 1 is 1.25. So I write it in the negative column. And the positive column remains as same. Okay. So what is the middle point of 1.25 and 1.5? Just calculate. 1.25 and 1.5. How much you are getting? What? What will be the Sweta? What is 0? Yes, 1.375. Please mute yourself. Whoever is there, mute yourself. 1.375. Okay. Yes, that's the middle point of 1.25 and 1.5. So what we got, the function positive or negative? Positive. Okay. So next iteration, therefore, positive means 1.25 remains same. That means the negative column remains same and the positive value goes to the positive column. I mean the new xn plus 1 goes to the positive column. Okay, next middle point of 1.25 and 1.375. $1.3125. Right, very good. The function positive. Okay, so if the function is positive, as Azizur has calculated and also Srijita, in the next iteration, negative columns remain same and positive column becomes 1.3125. Midpoint. 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 Uh, 1.28. Two decimal places. Shrutam, give your answer for two decimal places. That's what is asked in the question. If you are having the answer, also give it to me for two decimal places. Okay, so Srijita, we are getting negative here. Just correct me, okay? If I'm writing something wrong, I'm not having the solution for this. I'm not doing also. I'm just going as per whatever you people are doing. Okay, so negative means the new value will go to the negative column, 1.2812 and 1.3125. So I cannot stop till because I haven't got two consecutive steps same value yet. Two decimal places. Okay, so your midpoint after this, fifth iteration midpoint 1.2968. Okay. Function is positive or negative? Negative. Okay. Srijita and Azizur got the same thing. Sixth iteration, therefore, the new value will go to the negative column 1.2968 and the positive column remains same 1.3125. You can keep 4 decimal place, enough, don't increase it. Okay. Okay, so what is the midpoint next? 4 decimal place is fine because answer has to be in 2 decimal places. So what's the midpoint after this? Yes, 1.3046. Keep to 4 decimal places. Don't increase it. Okay, so we are very close to the solution. So function is negative or positive? Positive. Azizul got, yes, Sujita also got same. Okay, positive. 7th iteration, I think that will be the last step. Positive means new value goes to the positive column. So 1.3046 here, and this remains the same, 1.2968. Calculate the middle value. Yes, 1.3085. 1.3085. 1.3007 or 3085. 1.3007. So Azizul, just check your calculations. Sirish also says 1.3. So I think it is 1.3007. Okay, something wrong he did. Okay, so I take this value as 3007. And what about the function here? Positive or negative? At 1.3007? Negative? Okay, one more step we will go about with. We already got same, but here it is little different in Bn. So negative means 1.3007 will be in the negative column, and 1.3046 will come here. Just check on the middle value. One 1.3026. Actually, long back we got the answer 1.30. That's the answer. But little bit it's not matching here. So we are just continuing with this. Bn also matched. Only maybe this last 9th step we will take one more. And the function is negative here. So I think in the 9th step we get all same. So negative means the new value will go to the negative column, 1.30. So now it is the perfect. We got all same in 2 consecutive steps. So very good. All of you, those of you have solved. And what is the mid value? 1.3036. Okay, so that's the final answer then. Final answer is 1.30. We got long back 1.30 actually, but it was we were not getting it in these columns. Now we got here also. See, 1.30 and 1.30. So this is done perfectly now. So my answer is x is equals to 1.30. Okay. So really encouraging. You solved it. That was very good. We just learned the method, and very correctly with proper accuracy you have solved it with 9 steps. Okay. So that was really good. All of you who have been participating in the solution, exact answer you got. Okay. So this is the root of log e base x minus cos x equals to 0 between 1 and 2. 1.30. That's the exact answer for 2 decimal places. Yes, if you want little more, 1.3036. Okay. So I think in the PDF also we have this done. Let me check. Yes, but here they have done it little different way. Okay, same question, answer is same. Okay, compute the root of log x cos x correct to two decimal places. Can you tell me what difference they have than what you have done? I have been speaking a lot. You tell me how this same answer, same question, but method little bit different. Bisection method only. What they have done? Can you tell me how it is different from your solution? It's better
I
to tell
think
me in a sentence. Yes.
I think they have direct in the starting mode only. They have like when they have checked with F1, they found that it is minus 0.54. So they tried to extend more and they went much ahead, like 1.3, and they checked that they're getting negative, and that also close to zero. It is minus 0.005. So they thought to start from there only because from 0.113, if they take, then they could get much more accurate because that is much more closer to zero.
Right. So actually what they have done at the beginning only, before they started the computational table, they are trying to make the interval small actually. Okay, so what we have done, we have gone for the straightforward method that the root lies between 1 and 2. So we took very conveniently, we took actually the two values 1 and 2. We said this is 1 and this is 2, and the root lies between 1 and 2. So we computed F1 and F2, and we tried to see where it is negative, where it is positive, and we proceeded. They have done what they have done, they have tried to make it small actually. Okay, so what they have done, f of 1 definitely you have to find, and you get negative here, and f of 2 you get positive. We have also done that. At f of 1.5 they have again computed first, that is the middle point, and at f of 1.5 they got positive. So now they knew that the root lies between 1 and 1.5. So actually the same thing only they did, but they did it without the table, the first part. Okay, so then they computed f of 1.3 and f of 1.5, 1.4, and like this few values. And before starting the table, they concluded that the root lies between 1.3 and 1.4. And then also there were 6 steps that they had done. Okay, so I don't think it will save too much time. If you are very confident, then you can do like this. Otherwise, what we did was straightforward. We started with 1 and 2 because it was given that the root lies between 1 and 2. And in 9 steps, we completed. Okay. And they have taken also 6 steps, and there was initial calculation also actually. So time wise, not much difference. So you can shorten the interval at the beginning if you wish. Otherwise, no need, you can proceed. Okay, anyone has any question? So these were the two questions we did for bisection method, and little bit we want to start Newton-Raphson method after this. But if you have any queries, first let me know.
Ma'am, here like since we can directly in the beginning only we can shorten the interval. So similarly, like they have done, like they have taken one like 1.3 much plus. So like they have taken 1.3. Can you do it the like the upper value, that is 1.4? We cannot shorten it like 1.35 like that, and
Yes,
we can check.
yes, yes. The more you can do, it's better. The more you can shorten the interval, it's much better.
Okay, so if we do in this way, then it won't be wrong then.
No, nothing wrong. Then maybe iteration steps will be more less. Okay. Instead of writing so much, actually when you are practiced and you are little bit expert actually in bisection method, you will find it easy. This is why when I started the class, I showed you this diagrammatic representation. Okay, the diagrammatic representation is also very easy. I mean, you just have to find the mid values and the root lies between this and this. Like here, the root lies between 1 and 2. Then I found 1.5 and it was positive. So I know the root lies between 1 and 1.5. Okay. And yes, 1.3 and 1.4 we can calculate. And then I got 1.3 and 1.4. One has to be positive, one has to be negative. And then I know the middle point is 1.35. So I can just check on 1.35. More I do, more I shorten the interval, it is better for me. Less iteration steps I have and less to write also. Writing also takes a lot of time, writing a and writing b and writing xn plus 1, writing fxn plus 1. So in the calculator, if you can do it faster, it's fine. No harm in that. But you have to be a little bit proper and exact. So to begin with, we have the lengthiest table. That is this one, but simplest one. Okay. And more you can shorten the interval, that's better, which they have done here. Okay, so little bit we will introduce today Newton-Raphson method because time is short, not much can be done. And next class again we will continue next week with more of these questions. But a little bit I want to start today Newton-Raphson method. So, and if you have any questions, you can put in the chat box. I will answer for you. Actually, why I want to start Newton-Raphson method today? This is a better method than bisection method. It gives you better accuracy. Okay. So same question can be solved by Newton-Raphson method and bisection method. And always this is the one which is easier also. The computational scheme is much simpler, much easier. Okay. And it gives better accuracy. So you should have an idea also about Newton-Raphson method, because if in the question paper nothing is mentioned, actually hardly we use this lengthy method. This is quite lengthy, but you should know it. Okay, that's a different issue. And this is shorter, and the main importance of the Newton-Raphson method, it is more accurate. Okay, so we would just like to go about with this. So here you have to know that the iteration formula is for Newton-Raphson method, the iteration formula has to be known. Previously also we had an iteration formula, but that was very simple. Now the iteration formula is xn plus 1 is equals to xn minus fxn by f dash xn. Why we call it the iteration formula? Because the given present xn value will give me the next xn value. Xn plus 1 means the next xn value. Okay. So always when I have the present xn value, using this formula, I get the next xn value. That's what is called the iteration formula. That means in this case, you just need two columns to begin with, xn and xn plus 1. So we will start with a given xn value and we get the next xn plus value. Whatever I get here, I put it here. Again, I compute, I get the next xn plus 1 value. So this is how Newton-Raphson method goes about with. Okay. So the iteration formula is, it is so simple. Nothing you have to think of negative, positive, this, that, nothing. Okay. So you have the given xn value, and from this formula, from the iteration formula, you get the next xn value. That is xn plus 1. So just two columns are needed. You don't need much more than that. Okay. And the root lies between a and b. That part remains the same. That the root lies between a and b. Okay. Therefore, FA into FB should be negative, or the other way around. If FA, FB is negative, the root lies between A and B. That concept of bisection method goes about here also. Okay. And in the iteration table, the first value is the A value. So if the root lies between A and B, we start with the first A value. So that's all is required in Newton-Raphson method. You have to find the root lies between which two values, or maybe it will be given. So you know A and B, no problem. So we start with A value, xn is A to begin with, and then you have the iteration formula for xn plus 1. Okay, so let's just solve one question for this, the Newton-Raphson method. Okay, so find the root of x cubed minus 8x minus 4 equals to 0. So find the root of x cubed minus 8x minus 4 equals to 0 between 3 and 4. Between 3 and 4. So it is given that the root lies between 3 and 4. Correct to 4 decimal places. Okay, this is the question. Newton-Raphson method. So find the root of x cubed minus 8x minus 4 equals to 0 between 3 and 4, correct to 4 decimal places. So you just need to remember the iteration formula. Xn plus 1 is equals to xn minus fxn by f dash xn. Okay. So I start with the computational table. Before that, fx is equals to okay, before that, let us put fx value. Fx is equals to x cubed minus 8x minus 4. You need f dash xn. So f dash x you compute and keep it. 3x square minus 8. Okay. So find the root of x cubed minus 8x minus 4 equals to 0 between 3 and 4, correct to 4 decimal places. That's the question. And as we begin the solution, the iteration formula is something very important. So I have just written it once more, that xn plus 1 is xn minus fxn by f dash xn. Then the function fx from the given question, x cubed minus 8x minus 4, f dash x will be required 3x square minus 8. That's all. And we move on to the computational table. So in the computational table, first column is n, the number of iterations. The next column is xn. Actually, you don't need further columns, but just because we are doing it for the first time, we are making 2 more columns. That is fxn and f dash xn. Actually, these columns are optional. And the last column is xn plus 1. You need just xn and xn plus 1. That's all. Okay. So at the beginning, when we start, can you tell me what will be the value of xn to begin with? Because that's the starting point. Here we don't have any negative positive business. Yes, for your self-satisfaction, yes, right, xn is 3. Very good. Xn is 3. Just for your self-satisfaction only. Otherwise, it's not required, okay? You can find how much is F3 and F4 and you can check if F3 into F4 is negative. Because they have said the root lies between 3 and 4, definitely F3 into F4 will be negative. But Just you can check it and keep it. So can you tell me what is the value of F3 and what is the value of F4 before we begin the computational table? Yes, F3 is -1. That's very obvious. And F4 is 28. Okay. So now I am confirmed, only for confirmation, otherwise it's not required, that the root lies between 3 and 4. I got FA-FB negative. So I keep this calculation aside, that okay, fine, FA-FB is negative and I am on the right track. Otherwise this is not required just now. Okay. So I got this. Okay. So next, xn is 3, xn is a, okay, the starting value, the root lies between 3 and 4. So xn is 3, so you can compute fxn and f dash xn. That means simply you have to compute f3. We have already computed f3. That's -1. What is the value of f dash 3? 19. Yes, very good. Xn plus 1. This is the formula. Here we don't have any negative positive business. What will be xn plus 1? You have to just use the formula. Pratusha, just check it once more. Little bit decimals. Yes, 3.05. That's what you should get. Okay, 3.05. So in the next iteration, my value comes here to 3.05. Okay. So calculate next f of 3.05. You can calculate f of 3.05 and f dash 3.05 because time is short. I'm just giving you the values. So you should get 0.514 here from the formula. And in the next iteration, 3.0514 will come here. So since time is short, I'm just completing this now for the time being. So here you will get 3.051374. You have to just put the values, okay, nothing else. This is the last iteration, 3.051374. Here you will be getting 3.051374.2. Okay. And again, like bisection method, this is the root. Xn plus 1 is the root. So correct to 4 decimal places. So what is my root? 3.051. 37 becomes here also 37. So I got same. So finally my answer is 3.0514. 37 becomes 4. So this is my final answer. So in 2 consecutive steps, I got same xn plus 1 and so I stopped. I got 3.05137. And rounding off to 4 decimal places, my final answer is 3.0514. Okay. So please check on this. I have to take your attendance in the meantime. If you have any question, you can ask me. Okay, so that's all for today. We will continue with Newton-Raphson method again in the next class. I just wanted to show you very fast that this is a easier, shorter method. Okay, time is up, I think. Just a minute. Anyone has any question? We will again continue in the next class, definitely, because we have done it in a very hurried manner. Anyone wants to ask anything? Okay, fine. So we end here. You can check your Google Classroom for